In this example, we are going to do divisibility tests for 11. And similar to casting out 9s, a process known as casting out 11s also uses the notion of summing up the digits of an integer and determining if the result is divisible by 11. However, for casting out 9s, the position of the digits within a number is irrelevant. For example, if we had something like 531, if I wanted to determine if 531 was divisible by 9, I simply add up the digits, and if the sum of the digits is divisible by 9, then so is the whole number. 5 plus 3 is 8, plus 1 is 9. Obviously, 9 is divisible by 9. Therefore, 531 is divisible by 9. But then so is 135, 513, 315. So the arrangement of the digits is irrelevant. As long as they sum up to 9, then all of these are going to be divisible by 9. But for casting out 11s, it is the alternating sum of its digits starting on the right that we have to determine. Alternating means that the operation alternates between addition and subtraction. Therefore, the position of the digits of an integer when casting out 11s is critical. So as we look at letter A here, we have 6,281. So to determine if this is divisible by 11, we start on the right with the rightmost digit, 1, and then we do the alternating sum. So we'll do 1 minus 8 plus 2 minus 6. That's what we mean by alternating. We alternate between addition and subtraction. 1 minus 8 is negative 7. Plus 2 is negative 5, minus 6, that's negative 11. Negative 11 is divisible by 11, so therefore 6,281 is also divisible by 11. Now if we look at this, let's do it like this. We'll do 1 plus 2 minus 8 minus 6. And then if we wrote it as 1 plus 2 minus 8 plus 6. It's all saying the same thing. This is still negative 11. But writing it like this, we could expedite our work a little easier. So let's take a look at B. 23,727. So starting at the rightmost digit, and then we're going to count backwards for every other digit. 7 plus 7, that's 14, plus 2, that's 16. Then I'll do 2 plus 3, that's 5. Then 16 minus 5, that's 11. Obviously, 11 is divisible by 11. Therefore, 23,727 is also divisible by 11. Let's try C. 2,568,451,915. Start at the right and we'll count backwards. Every other digit, 5 plus 9, that's 14. Plus 5, that's 19. Plus 8, that's 27. Plus 5, that's 32. We'll then take the next to the right digit here. 1 plus 1, that's 2. Plus 4, that's 6. Plus 6, that's 12. Plus 2, that's 14. 32 minus 14, that's 18. 11 goes into 18 one time with 7 left over. We could also continue this process here of doing it as 8 minus 1. So 2,568,451,915 is not divisible by 11, but it will have a remainder of 7. So I'm just going to put it right up here. 7 will be the remainder. Let's try D. 78 billion, 678 million, 662,681. Again, starting at the rightmost digit and counting backwards every other number. 1 plus 6 is 7, plus 6 is 13, plus 8 is 21, plus 6 is 27, plus 7 is 34. We go to the next rightmost number, that's 8, and count back every other one. 8 plus 2 is 10, plus 6 is 16, plus 7 is 23, plus 8 is 31. And we subtract 34 minus 31, that's 3. So 11 does not divide into 78,678,662,681. If we were to divide it in there, it would have a remainder of 3. So I'm just going to put it in right up here. This will have a remainder 3. Let's take a look at E. Now, I'm not going to write out this whole number here. So if you could follow me up on top up here, starting at the rightmost digit and counting backwards every other number. 0 and 4, there's 4. 6 more, there's 10. 1 more is 11. 2 more is 13. 7 more is 20. 1 more is 21. 6 more is 27. And 1 more is 28. Taking the next rightmost number, 8 and 6, that's 14. 0. 7 more, that's 21. 7 more, that's 28. 2 more, that's 30. 7 more, that's 37. And 2 more, that's 39. And then we subtract 28 minus 39. That's negative 11. Negative 11 is divisible by 11. So this big number here is also divisible by 11. And finally for F, 9,097,740,683. The rightmost digit, count back every other one. 3 and 6 is 9. 4 more, that's 13. 7 more, that's 20. And then 0, so this is 20. The next rightmost number, that's 8 and counting back every other one. 8 and 0. And then 7 more, that's 15. And then 9 more, that's 24. And then 9 more again, that's 33. 20 minus 33, that's negative 13. Now to determine the remainder, so therefore 11 does not divide into 9,097,740,683, but to determine the remainder, we'll do a practical approach with our number line. If this is negative 13 here, here's 0. So at negative 13, I come back 11. I'm at negative 2. I come back 11 more. I'm at 9. So this is going to have a remainder of 9. And as you notice, we didn't even need the use of our calculator. And there we have it.